Okay, question 6. Solid, liquid, and gas are three different states of matter. Describe the difference between solid and gas states in terms of the arrangement and movement. Alright, so we do not need to describe any liquid, we just need solids and gas. Difference in terms of arrangement and movement. How many marks are you worth? You are worth 4 marks. Alright, okay, so quite a longer answer here. Worth always having a bit of a plan. So we're going to talk about solid, and we're going to talk about our gas, and we have to mention the arrangement of particles, and we have to mention the movement of particles. That will give us 4 things. So if I can tick these boxes each time I do it, I know that I've done it. So, solids, let's talk about the arrangements. Solids have particles which are arranged in a regular formation. And we should also say that they are touching. So that's our arrangements. How do they move? The particles in a solid vibrate in a fixed position. Okay, we've done that for both, so we should be up to 2 marks so far. Let's do the gas. In gases, we talk about the arrangement. The particles are arranged randomly, not touching. How do they move? In a gas, particles are free to move at a range of speeds and directions. We should also say, yeah. So, yeah, they spread. They are far apart. So let's have a read through our answer and then just check we've answered the question. We've done that. Solids have particles which are arranged in a regular formation, touching. Yep. The particles in a solid vibrate in a fixed position. Yep. In gases, the particles are arranged randomly, not touching. Yeah. We should probably have added in there that I suppose we already have, but they are arranged randomly and they are far apart. Whereas in the solid, they are touching, but they are close together. So we've done those two. In a gas, particles are free to move at a range of speeds and directions. Good, and we should obviously use the word to move randomly at a range of speeds and directions. I think that's tidied that answer up a little bit, and that's fine to correct it like that. The examiner will be okay with that. What is meant by specific latent heat of vaporization? All right, well, this word vaporization, vapor, is a liquid turning into a gas, and specific is a unit of volume. So it's how much. So specific vibration, specific latent heat vaporization is the amount of energy required to change a liquid. Remember, to change, it's a specific volume, so it's 1 kilogram of a liquid into a gas. The amount of energy required to change 1 kilogram of a liquid into a gas. Good. That covers those. Okay. When a kettle boils 0.018 kilograms, get out the highlighter, change it into steam, calculate the amount of energy required. Specific latent heat of vaporization is 2.3 times 10 to the power 6 joules per kilogram degree Celsius. Right. So we need kilograms. Yes. We need joules. That's energy. That's fine. So no conversions. That is going to be a mass. We have a mass. We need an energy. That's what we're trying to find. And we have got our specific latent heat. So the first thing we need to do is we need to find the formula. Specific latent heat. And again, there's only one of these. So let's look it up on the data sheet. Get rid of that one. Get rid of that one. Let's have a look. Specific latent heat. So we scroll through. Can't see anything there. Can't see anything. Have I missed it? Have I missed it? Okay, there we go. I did. I missed it. Specific latent heat. Thermal energy. So energy is equal to mass times specific latent heat. Okay, so energy is equal to mass times by our specific latent heat, which we represent with an L. I'm just going to write S. L. There we go. Same as that then. So let's input that data. We want energy, so that's already the subject, so we don't need to rearrange. That's good. So 0.018 kilograms times by 2.3 times 10 to the power of 6. We do not need to fine tune this anymore. We can just get our answer. I'm going to put my answer in here though, because I imagine we're going to get a big number here. So we might need to round it a little bit. Let's have a look. Come on, calculator, play nice. There we go. Right, so we've got 0.018 multiplied by 2.3 times 10 to the power of 6 gives us 41400. Well, it's not that big of a number. I think we can just pop that straight into there. 41400 joules. Or just check your sums one more time, especially when we've got that standard formula. I'm just going to do that. It's just good practice to do. Let's take 0.018 times by 2.3 times 10 to the power 6, 41400. Yeah, absolutely right. And there is nothing there saying that we need it to a certain number of significant figures, so that's fine. Right, this graph shows how the temperature varies with time for a substance as it is heated. The graph is not drawn at scale. Right, it's a change of state graph. Always label them up. So that is a change of state. And as is that. That is a temperature increase. And as is that. We've got two changes of state. There's only three states that matter. So this is going to be a temperature increase of a solid. This change of state there is our solid turning into a liquid, so that is melting. This is a temperature increase of the liquid. And this is the change of state of the liquid going to a gas, so this is boiling. All right, that should help, hopefully. Explain, kind word, so we're going to say why. What is happening to the substance in sections A to B and B to C? So we're going to start with A to B. So A to B is here. So what is happening, well, we've already said, is a change of state, and it is melting. So A to B shows a change of state from a solid into a liquid, and we call that melting. 1 mark. We need 2 marks for each one, so we have to explain it. Why does it look flat? And that's because the temperature is not increasing. So change of state, the temperature does not increase as energy is used to overcome forces between particles. And we say that that is a gain in potential, not kinetic. So, explain what is happening. We've got a change of state, and the temperature doesn't increase as the energy is being used to overcome the force between the particles. So the potential energy is increasing, not the kinetic. Yep. Sections B and C. Okay, we have got a temperature increase here, and it's a temperature increase in the liquid from B all the way to C. So we have got a temperature of the liquid increases so explain it. So why temperature increase as the particles gain kinetic energy when heated, and it increases to C. So why needs to C? The temperature of the liquid increases. The temperature increase stops at point C, which is the boiling point. So it won't go any higher than that because it'll have to do a change of state again and overcome the forces between the particles. 4 marks. Temperature. Read it back. Make sure it makes sense. Yeah, good. All right, that's the end of question 6.